That is mine. I'm sorry. You have to move one more. Okay, perfect. Thanks. Perfect. What a treat. These are all Kaggle Grandmasters, 8 of them, and I think there's 2 more in the audience. Maybe they left already, but if you're around somewhere, you're welcome to join the stage. This is the largest concentration of Grandmasters in the world, I think. So applause to those guys. Let's start with the youngest. Who can guess his age? 17. Very good, 17. Please introduce yourself.
Yeah, so I'm Mikel. I'm the youngest Kaggle Grandmaster. That's my gimmick. So yeah, I'm 17. Started Kaggle about 3 years ago, and then since then sort of just been self-learning and doing competitions and getting better at it.
Hi, I'm Darragh, and I've been at Kaggle, I'd say, about 3 or 4 years. And I'm an AI engineer in the healthcare space with Optum. So doing some interesting work there, and also trying to learn as much as I can on Kaggle.
Hello, I'm Mathias. I'm data scientist here at H2O and working primarily on developing driverless AI. And my name at Kaggle is Ferran, and it's just an awesome platform. And if you're not competing already, just get started.
Hi, I'm Branden. I'm a customer data scientist at H2O. I joined Kaggle 5 years ago, but I only knew Excel at the time, so I spent another 1.5 years or so learning R, and so I've been on Kaggle competing actively for about 3.5 years, and yeah.
Hello, I'm Marius. My Kaggle name is kazAnova, and yeah, I've been working for H2O almost 1.5 years now as a competitive data scientist, mostly on driverless AI, and yeah, I have my fair share of Kaggle competition. I think I have participated in more than 120. Yeah, that's me.
Hi, my name is Dmitry Larko. I am a Kaggle Grandmaster. No way, right? I participate in a lot of different Kaggle competitions. I opened my Kaggle to myself like 7 years ago, and I'm a H2O data scientist.
I'm Jean-Francois Puget, known as CPMP on Kaggle. I'm double Grandmaster, and I'm better at speaking than competing, because I'm first on the forum. I work for IBM doing machine learning, and machine learning is a long-term interest because I had a PhD from previous millennium. As you can see, I'm not the youngest here, but machine learning is really my interest for many years.
Thank you. Hi, I'm Sudlai Rajkumar, called as SRK in Kaggle. So I'm working as a data scientist at H2O.ai. I've been Kaggling for about 5 years now. So I'm a Grandmaster in both competitions as well as in kernel section.
All right, let's get going with questions. If you have questions, please submit them to Slido. But what is the #1 advice you would give to an average data scientist that you already know they need to know this? Like, it's something they just have to listen to. Right?
I think what I would say is that there's a big difference between learning something in theory and actually trying to do machine learning in practice. Because like you've seen the rest of the day, it's all about feature engineering. It's all about figuring out what's going to be good and sort of just getting your own ideas and implementing them, as opposed to actually knowing the equations. Not that important, you know, because someone's done the equations for you, right? It's still programmed for you. So it's just about getting that intuition. And so my advice is to get stuck in, do Kaggle competitions, and get that intuition.
Yeah, I totally agree with that. And one thing I find myself struggling with a lot is when you develop a pipeline or something, trying to not getting stuck in that for too long, trying to move to something new, because I think we're all in for learning. What we can learn out of new methods, feature engineering, models, to try and constantly push yourself to move on to the next thing instead of spending a lot of time just tweaking one pipeline. Because
yeah, generally you get more out of it during the competition, and also you learn more that you can apply in the future.
Yeah, and so really one important thing for myself was after I finished my studies, I started after that with Kaggling, and I was quite confident actually, because I thought, oh, I have so good educational background now, and then I got into my first competition, and I got grounded a bit, and then all the fun experience kicked in, so I really wanted to learn what I'm missing, and I figured out that I missed a lot, so that academia teaches you not the things that are really necessary out there, so you have to figure it out on your own. I mean, that's always been the case with university. A lot of things you really need, you have to teach yourself. And Kaggle is really the best platform to get started if you want to get better at all the things which are part of a data science pipeline.
I don't know if I have too much to add compared to what all these guys just said, but I think I agree with Darragh about just trying different things, because I feel like sometimes in a competition you just get stuck doing one thing and trying to perfect it, and then you realize after the competition that someone tried something else that you were thinking about trying but you just never had the time to do. So I think like taking more of a shotgun approach towards things rather than, I guess, focusing on one single thing.
I'm not sure what the question was.
The single best advice you would give to
yeah, I mean, you just, okay, I see now. Then your answers make sense. I think yeah, I mean, you need to get your hands dirty. Don't get demotivated, because even the work, science, it might be a bit tough. Sometimes you see all the pile of notations people use, and it might feel a bit intimidated to enter into the field, but you shouldn't. I mean, obviously it takes a certain amount of time, but I've been able to do it from an accounting background. I know a lot of people who have been able to do this with very little, not very strong background, so I think it's a matter of putting the time, trying to learn. It is a very open community. The data science community is one of the best, more generous communities out there, dominated by open source works. People will help you. Don't be afraid to ask. And generally, that's my message. Get your hand dirty and don't be intimidated.
Yeah, so basically, actually, we have a lot of advices already, so I can actually make like some sort of a summarization. You're supposed to know your algorithms, right? But that's something that everybody knows, right? You're also supposed to know the metric you're trying to optimize and know the data, right? And especially keep in mind like a difference between train and test data set on Kaggle computations, because in some computations that actually can give you a lot of insights.
I would say the hardest skill to get is to properly evaluate model performance. It's very easy to get full download, install open source, train models, get 99% whatever accuracy or any other metric, and your model is just learning the training data and not generalizing. And entering a Kaggle competition is a wake-up call if you don't do it right. You believe you're good along the competition, and the last day when the private data set is used, you discover that your model was awful. And so learn how to evaluate properly your model, and it's hard because you must not overfit to the training data. So practice, Kaggle is one way to learn that. To me, this is the most important skill.
Yeah, thank you. So in my case as well, like as people are mentioning, so like being hands-on is one thing which has helped me a lot, like in grooming my career. So like say in case of Kaggle competitions, I try to participate in multiple competitions, so I try to get to solve different types of problems. So and in that way, like I improved on my data science skills.
I wonder, how many hours do you spend a day? Is it 0.1 or is it 5? What would be your over the last year or two, your average?
Ooh, if you're asking average, unfortunately, probably over an hour a day for me. But it really depends on if I'm doing a competition seriously and it's coming up to like the last week of the competition, then I think we can all say that we spend way too long doing it, sort of missing sleep and all that. But then again, there are times when you're not working on a competition or you're just doing one for fun, and then it's really, whenever you feel like it. But I think overall, if you're trying to be in sort of a prize winner or a top 10, it really, if most of us, it's not like, oh, we just press a button and it works, right? You really spend a lot of time doing it.
Yeah, it's the answer is a bit embarrassing sometimes, how long you spend on it. I'd say when I find, like, if I'm in a competition and I start to do well early on, I end up spending a lot of time in it, maybe 2 or 3 hours a day, maybe a bit more at the weekend. And that'll be on top of work, so a lot of time. But I enjoy it and do it mainly out of learning new techniques, because I find it interesting. So sort of find, instead of watching Netflix,
Correct.
do Kaggle.
Yeah, it takes 10,000 hours to be a Grandmaster at anything, right? So they're probably underestimating the hours even, but it's
Yeah, I cannot tell how much hours I spend on average. I don't know, but it's definitely, if I'm really into a competition, it's a bit like an addiction. So for me, it's like I have so many ideas in mind, I want to try them out, and it's really painful to have to wait, because then I have to implement the stuff, and then I have to try them, and then I see, oh God, it's not working, damn it, next one, and the list gets longer and longer. And so sometimes it is like, it's really more the way, how can I find sleep and get out of it? Because if you're really diving into a competition and you have actually a chance to compete towards top 10 or better, then it's for me personally, it's like I use every 3 minutes I got for it.
For me, it could be sometimes 10 hours a day. I get to do it for work sometimes, so I'm doing research and stuff like that. So one of the things we're working on at H2O is reading documents, or trying to figure out where in a document an invoice date is. So I was using fast RCNNs for that, which happened to be what I used for the, right now there's the RSNA making bounding boxes around where pneumonia might be. So for that competition, I probably spent like 8 hours a day just looking through the code, trying to make changes, trying to figure out how it worked and how I can, what changes I would need to make it work for our process. So for something like that, I might spend, 8 to 10 hours a day. But for the home credit competition, which my large team of 12, we got second place, but for that, I didn't do a whole lot. I wrote some code that was kind of in a loop and made 20,000 features or something like that, ridiculous. And that was pretty much it. I didn't do maybe an hour, 2 hours a week maybe on that one, not too much.
Yeah, probably more time than most. I should not embarrass myself further, but I should say in my defense, but there is good overlap with my work.
totally.
Well,
Totally work.
on the last competition, which I was able to make, end up with 6 out of 2,000 something, it was my latest solo gold medal. Out of curiosity, I calculate how many hours I actually spent. I spent 4 hours a day for 3 months. So that's a lot.
It depends if you include dreaming or not. No, I dreamed of my current competition last night, so it was not a nightmare, so that's good. I would say like you, 3-4 hours. I have a day job. There is some overlap, but maybe not as much as for you, Marius. So spending a bit every morning, preparing runs, watching them during the day, and finalizing in the evening.
I spend around 3 to 5 hours on an average, but my system used to spend around 15 to 20 hours.
So what's your process? Do you just do random attack? You try all kinds of stuff? Or do you first set up a validation scheme or think about the metric? Maybe you reframe the target column first? Or how do you do it? Does it depend on the problem? Of course, it always depends, right? But is there something like a systematic way to make a better process? How is it that you made it into this stage, let's say?
I think that in an ideal world, like when you start competition, you should, first thing, setting up validation is really important because you want to be able to work out locally how good your model is so you don't have to keep uploading to Kaggle. And then also sort of visualizing the data and trying to figure out, sort of find interesting bits of information that you can use, feature engineering, things like that. In practice, for myself, what I tend to do is I tend to download the data, stick it into XGBoost, upload it, and then sort of sit happily for a couple hours while I'm at the top of the leaderboard because no one else has downloaded the data yet. But that's my approach. Then I will go back once I'm on there, and I'll go back and I'll start looking at the data more and trying to do that. But I really should do more of what I preach.
Yeah, I think the pipeline's pretty similar. At the start, I try and get an idea of how well people are doing on kernels, and then set up a validation set. I think that's something that's very important, and it's often underlooked. Having a good validation set, run a simple model yourself locally to make sure you can get close to that, whatever the scores on the leaderboard are, and then just spend a lot of time trying to understand the data, a lot of time working with that part.
Yeah, it's getting already repetitive, but first step is to set up a good foundation for cross-validation. So I always spend my first couple of submissions to train a model, and I know that it's not good, and I improve it a bit, and then I want to see a relationship between my validation score and the leaderboard, and if it's not there, then I have to think again about, okay, what's going on, why is the validation not working, and that's the first step of the whole process. So I'm not starting with deeper analysis or more modeling before I don't have a solid validation framework established, because that's the bread and butter of everything else what is following. If your validation is bad, everything what comes after it is not working.
Pretty much the same as Farron's. I'm not going to bore you with repeating it. Yeah, CV.
Right. I think on top of what the guys have said, I will add what determines the winner is obviously the time you put in. You have more time to search for different things, patterns in the data. Making good partnership. Data science is a team sport. Being able to find people that can complement your skill set, have different experience on different techniques, or they're able to seize the data from different angles, can lead to very diverse solutions and normally better results. Having access to the right tools and having good hardware support, you can run more experiments at larger scale, cover more ground. Some level of automation, I think it's quite important. You know, you don't have the power to search for everything. You need to kick in automated things while you focus on the things where it can really matter, where you can extract more information. So some individual understanding of the data, try to get a bit more context and get specific ideas of how to solve a specific problems, I think can really help. Then a little element of luck, I think, is also a good boost.
They said it all already. I would just add, trying to see if other people have not worked on the same problem and published papers. Especially if you use deep learning, it's evolving so fast. I see in the deep learning competition, the one that win are the one using the latest papers.
All right, let's now move on to the Slido questions. Thanks again, Grandmasters, for answering all the questions so far. Let's pick the first one. Why aren't there any women Kaggle Grandmasters on the stage? Are there any in the audience? Does anybody know anyone? We would love to encourage participation. I mean, it seems like it's male-dominated, and it's possibly true, this bias in this data. Anything we can do?
I mean, I think that it's important that people don't think that you need to do a degree or whatever to get into data science or into Kaggle. I think that it's almost a softer science than people think at first, because it's really about experience and all that. So I think encouraging people maybe who don't have a background in machine learning to also give it a go, see if it interests them. I think it's to open it up to more people would be quite good.
Because the best software engineers were women in the early days, right? The Apollo mission, space mission was all programmed by women. So it's definitely the attention to detail is actually better of women. I think that's the state of the art of the research. So men might be just more bullet. What is it called? The shotgun approach. Maybe there's some kind of a brain chemistry that makes it try everything kind of.
And to be fair, there is improvement, and there are female grandmasters. I mean, I don't see any serious obstacles right now to participate in that platform that would be based on gender, for example. It's just a matter of feeling comfortable that you as long as you don't feel bad if you don't get very good, if you don't get it with the first try. That's the only thing that can keep you back, in my opinion, right now, in a platform like Kaggle.
And what's the point now that we have driverless AI? Why even compete in Kaggle? Or actually, I would rephrase it. Is there any use of driverless in Kaggle?
Well, we kind of use driverless AI to get insight about the data during the Kaggle computations, right? We're not allowed to use it for final submissions, that's for sure, because Kaggle is a commercial software. But it doesn't stop us from using it, to get insight with features actually interact the most. But it's still, I mean, I think Sergey in his presentation actually compared driverless AI to autopilot, basically, right? And it is basically an autopilot, but you still have to, you have to take off your plane, and actually land it back. It's still a result of actually additional things you need to do. You still have to think about, like carefully designing your experiment, your validation schema. You still need to, try things by yourself, like pilot actually learns to fly, even if they do have an autopilot available. They still actually know how to land it and how to operate their airplane. He is pretty much the same. So driverless AI, it's a extremely useful, sophisticated, automated tool, but it doesn't have any insights about the data you can actually use. It doesn't have any domain knowledge. It's just, it performs like a huge, relentless search. So it's kind of help you to speed up your search, but doesn't replace your insights and your looking into the data.
It is also meant to be production ready, which means that it may not be always suitable to win a Kaggle competition. What I mean, for example, in a Kaggle contest, you're allowed to look at the test data. Obviously, you don't know the answer, what you're predicting, but you can see the distribution of the test data, and you can use that information to enhance and enrich your training data, and this is something that quite often we do. I mean, you probably don't do it in a production environment, but you're allowed to do it in this competitive context because test data is available. So you see there is still room for manual intervention and, but in any case, an automated approach, I agree that raises the bar, but we can, if everybody has access, we can just push the boundaries even further with individual effort.
So in general, like when I start Kaggle competitions, what I used to do is like say I take the data set and run XGBoost model or light GBM model. So previously, now what I'm doing is like say I'm just running a driverless AI and getting a baseline and also getting the important features out of it. So now that the baseline is high, I need to work more hard and to beat that. So that's how I'm improving myself by using driverless AI.
And another thing maybe to add is that tools like driverless AI can actually take the boring part of you away, right? So actually that's what the data scientist has to do, but doesn't want to do all the time, like dealing with how do I deploy my model and stuff like that. Such things can, I mean, I'm okay with when an automated system makes it for me because I don't want to deal with that. For me it's boring. I want to get more data insights. So actually what's the human access that? I want to spend time in that, and tools like driverless AI is just a help to find more time for the really cool things. I think it's a little bit like in chess. I mean, nowadays the best chess engines, no Grandmaster in the world can beat them, but they're still playing chess. So we could ask the question, okay, why is still why are still people playing chess now that the computers are so much better at them? But they, on the other hand, use those computers to improve their own games, finding more insights, so combining the power of artificial intelligence and the human brain. And I think that is also an interesting point of view on the whole thing, because currently it's still like really separated, right? So we don't have that deep understanding of the human brain yet, and artificial intelligence is still kind of shallow. But that will change, and that is more like I would look at this.
There was a presentation earlier today that showed that chess enhanced by humans, that the robots plus the humans together beat the robots always, so 58-0 or something. So the combination of humans with the machines is always better. And I think the same is true here, right? So your Kaggle insights will help your performance as a data scientist, and it doesn't hurt that the machine is there as well. Do you use R or Python? Can you give a very quick, short overview of what tools you're using? Or do you use Scala, or what is it? Do you have a supercomputer at home or just a laptop?
So I'm using Python mainly, pretty much for everything. I think we may have a couple R users here who are still sort of stuck in those dark ages, but never mind. In terms of computing power, having access to a lot of it is helpful, and I think we all have access to quite a lot. So, but there's a lot you can do with just a normal desktop or a laptop. It's really just that extra edge, which I will admit is there from having a lot more computing power. In terms of favorite tools, I'm still quite a big fan of XGBoost. It sort of seems to work on everything. I know everyone else has switched to light GBM, so there's me in the dark ages, but you know, I still seem to do better with it, and I prefer it, so I like XGBoost.
So for myself, I'm an R user, and I find data table very good, so it's great to see the presentations here today on it, and I find that very good for munging data, because it's coupled with R, it does very good visualizations. So you can quickly iterate over ideas, and it's quite flexible to manage ideas and see the results of that, see how it would look like within a model. At the moment, I'm spending a lot of time with Keras and TensorFlow to try and, because I think there's a lot of levels to what you can do with deep learning. So spending a lot of time with that, and I enjoy that. I was thinking it's sort of a love-hate relationship. I like it, but it hates me. Yeah, so.
Yeah, for me it's Python mostly, coupled with C++ if it's like time-critical code. And basically all the libraries like XGBoost, LightGBM, or PyTorch, Keras, etc. So the common stack, which is nowadays used by almost everyone, I would say. That's what I'm using as well.
Yeah, so I'm an R user mostly. I do deep learning stuff in Python, but in R, I use a lot of data.table. Shout out to Matt, who does a lot of work on that. Matt. But yeah, so for deep learning, I've been using PyTorch lately. I used to use Keras, been using PyTorch a lot more. Then yeah, obviously XGBoost or LightGBM for other machine learning stuff. But yeah.
XGBoost LightGBM for gradient boosting, scikit-learn for random forest implementations, liblinear, libsvm for linear models and support vector machines, and follow the regularized leader normally in Python implementation. TensorFlow with Keras for deep learning.
It's kind of interesting. Nobody mentioned H2O actually, so I'm going to do that. H2O. So, H2O, I kind of love PyTorch, but usually I mostly use Keras. Don't know why, it's kind of strange relationship. but obviously you guys actually mentioned everything else. So basically, on Kaggle you always have like a pretty more or less classical set of algos you're always going to use.
Python, the same. But I spend time writing efficient Python code. It's very easy to write very slow code in Python. And if you have a limited time to compete, it will be bad.
So yeah, whatever like Marius was telling, I am also a Python user, so I use what Marius was telling most of the times. So in addition, recently, I mean, I also started using driverless AI to get that feature interactions, which features are useful and so on, so that like I can just use them in my models.
So I like that second question, does your validation set design match real-world validation sets? Or more generally, what you do in Kaggle, is that useful for real-world production use? Or are you really just tweaking some kind of a leakage problem and playing Sherlock Holmes in that local CSV file? Or is it actually useful information that you're learning?
I think sometimes of course there are leakage problems, and that's happened a lot lately actually on Kaggle, where sort of there's accidentally been additional information in the data which lets you do well on the leaderboard that perhaps you wouldn't have in real life. But I think for the most part, it is sort of applicable to real world. And what tends to happen is when you do a Kaggle competition, the top solutions will be sort of monstrosities of ensembles that actually, when you rerun them, you'll get a different result. But really, then the organizers can do is then from the top solutions, they can take the insights that are in there and sort of make like a diet model with sort of just the useful stuff that is maybe a little bit worse. But so I think it's still useful for the organizers. And in terms of whether the validation set matches, I think once again that's up to the sort of the organizers. If you want to be able to predict the future, then you should give us a test set that is in the future. But yeah, I think for the most part, Kaggle is quite useful for companies. I mean, that's why they keep coming back. But it's, you know, they will have to do some tweaking on those solutions.
Yeah, it's a good question. I think there's a lot of overlap, more than is sort of recognized sometimes. I think it's the thinking of how to represent data for a problem is quite important, and I think getting comfortable with tools it makes you better able to think about other things outside of the tool. If you're not as worried about am I using the tool correctly or whatever. So I'd say from those two perspectives, like I've seen a lot of use cases professionally that it could be drawn on ideas taken from Kaggle.
Yeah, I would also say that's really useful, because actually the problems that are in Kaggle are actually real-world data sets. So sometimes they are not properly set up, but and leakage can make a huge impact. And of course, if we as competitors find a way to exploit leakage, we do it because it makes our scores better. That's how the game works actually. But consider the same problem now as in your day job, and you are not able to identify that leakage. And I don't want to know how many models are out there in production which are really bad because they are trained on leaky data. And actually, that is a really important skill to develop for your own, to identify, is that model what I'm building here, is it actually useful? Is there any leakage I have to think about? Because most of the time those leakage issues start rising at the very beginning of the pipeline, in the data collection or data storage states, and not necessarily only at the stage of the modeling itself. So I think that makes it even more useful because you acquire skills there that you would really need as well in your day-to-day job if you're a data scientist and you have to build such a data science pipeline.
I also have very little to add here. I mean, it was basically pretty much covered, but obviously there is a lot more going on from the point you collect the data, you set up the problem, and then how you take the results, and you productionize and you utilize that. And sometimes it is very difficult, and people are critical about Kaggle having only one data set. It's just, and you need to make it so that it can be used in a competitive context, so you have a common measure to test everyone. And quite often there are pitfalls. You know, people introduce leakage, introduce stuff which they shouldn't be there. So I think having that experience, you definitely learn a lot about how, you know, what is the best way to represent your data to be able to avoid such problems. But yeah, I mean, I think generally this is a very obviously important matter which needs to be, you know, very analyzed.
I think we answered have you hacked the Kaggle scoring. What people do is not scoring is documented. What people hack are the target of the test data. This is leakage, all this discussion. It's amazing how good the Kaggle community is good at finding leaks, finding signal that the organizers thought they had removed. It's amazing. If there is a leak, it will be found. And this happens in reality as well. So the ability of finding a leak is you believe you have new data, you know nothing about the target, but in fact, you included the target somehow in preparing the data. And this happens in reality as well. It's a big danger. So learning how to detect this is also useful. Even if it looks like a drawback, it's actually very useful.
You good?
Maybe pick another question is, do the 9 of you Grandmasters ever think yourselves like Ocean's 11 and wanted to predict the next lottery win? We wish we could. It's more difficult. But I think most of us, we are engaged, I think, in some form of activity to predict something which may yield some return. I know some people do Bitcoin predictions over there, right? Mikel?
Something like that.
Yeah. I also try to optimize my own portfolio. I mean, we all try, I mean, maybe that's the problem. If we work together, we can make more. Yeah.
To be oceans
together.
I also would like to add, you know, it's not very efficient to predict the next lottery win because the pool is too small, right? We have to wait for, you know, to pool to increase basically. So as soon as jackpot actually becomes bigger, that's would be more effective, you know, spending your time for. So next lottery win is useless to predict.
We also know that half the money is gone already, right? It's not a very good way to make money. The expected return is pretty low. Is it a science, or is it all just random hackery, trying to make gold out of a rock?
It's both, to be honest, right? So it does has actually science inside because you still have to create hypotheses and test them. You still have to, you know, be very rational and not emotional about, you know, what your beliefs on the data in the prediction of your model. You still have to, you know, basically criticize your approaches over and over again, build the right validation. So a lot of actually of scientific approach to the in the data science, basically into the computation. But it does require some hackery as well, like deep learning, for example. There's tons of hacks, you know, actually not been proved by like some without any theoretical proofs at all. But they work, so we just use them.
I think it's a science by the method. You make hypothesis, you design experiment to test it, and depending on the result, your hypothesis is confirmed or not. And the basic hypothesis is this feature is going to help my model. So it's simple hypothesis, but you have to test it in a scientific way to make sure that it's true or not. So if you've trained in a scientific domain, you can do well in data science. For instance, physicists, they usually become great data scientists. It's not by chance. Then, of course, there is also black magic as well, but there is some science.
Have you hacked the Kaggle scoring algo? What was that answer? Oh, sorry. But in any case, I mean, this is how we made it that high, right? I mean, we found a way to secretly increase our scores. No, but occasionally people do find faults in the either in the scoring system in general or in a specific competition, and generally it is quite an honest community. These faults are identified and
yeah, in one
resolved.
of the competition, actually what happened was the metric was AUC. So what people, I mean, one of the other Grandmaster did was to actually predict the actual predictions. I mean, and then did a 1- of those predictions. So it gave a score of 0.0 something of the sort. So finally, on the very last day, he just reversed the scores, and that way, like, he hacked the system to get into the first place. So no one else knows that, like, he is actually improving his score. So that's one way, like, people hack.
I want to point out a question. Someone asked whether they should fear joining Kaggle, and that's something I hear quite a lot, but it sort of doesn't make sense to me, because it's not like you get kicked out of the secret club if you're at the bottom, right? So when I joined Kaggle, I sort of barely knew how to write Python. I had no idea what I was doing. I was going to Kaggle kernels, taking code that other people have posted, like changing the parameters and just sort of clicking run over and over again. And so back then I wasn't doing very well, but it's sort of doing that led me to actually figure out what was going on. So it's not a case of learning how to do machine learning, okay, now I'm ready for Kaggle. I feel that that's actually part of the journey, and even if you have no idea what you're doing, it's still good to have a go.
In German, there's a saying, the path is the target or something, so keep doing what you like doing. And of course, I guess you have to like it, right? You can't force somebody to do this, but if you have a little bit of this addictive personality, you will definitely enjoy it. And I think it's good for your career. It's good to learn this stuff. And even though there are tools out there like driverless, you don't need to stop thinking about the depth of the trees. It's better if you understand what that is, right? But you shouldn't have to do everything by hand all the time. And is there any last quick hacks that you can share, like some kind of a secret trick? Like I know Dmitry has a secret trick that he applies at the end of Kaggle. I'm not sure if he's willing to share it, but are there any like one short summary tricks that you say, just do this, or give us a hint of what you did to make your score go up?
Sleep less, try more.
No sharing? Okay.
We want to keep our positions, right? Can't give it away.
Great.
Now, never give up. Until the last minute, you can make progress. It happens a lot.
How about taking other people's submissions and averaging it and submitting that? I mean, everybody is doing that now.
Oh, no, a tip. Beware with whom you team.
Mm-hmm.
There are some rules on Kaggle, and if you break them and you get caught, you're removed. It happened to me.
Also look for last minute.
But I was not the guilty one.
Look for last minute kernels that have high scores. If you're quick, we might just click it and get a good score.
Keep a submission till the last minute,
The last minute, keep following the results.
There's also actually good advice, do not start a competition earlier, because somebody can find a leakage, and that means you waste your time, basically. Just wait for a couple of weeks, People will write kernels, people will find the leakage, and you will just, use their findings.
What do you think about the fact that you can make 2 submissions? It's not quite fair, right? You should have 1 shot, not 2 shots. Like, you always have like some kind of a backup, and in real life you might not have 2 shots at going to production.
I mean, so yeah, Kaggle has a thing where for the private leaderboard you choose any 2 submissions, and then the best score from those 2 is the one that actually counts. And I think that it's not that indicative of production, but it's nice because it allows you to try sort of 2 different ideas, that you don't know. One might actually be better than the other. I think it sort of gives you that peace of mind. It sort of lets you sleep before the competition ends. A little bit.
And a good strategy, I guess, to select which these 2 submissions might be, because you might have thousands of models where you could select this. You normally, something that I have done and kind of helps is I normally pick the one which work best for me internally in my internal validation framework. And I also select the one that work best on the public part of the leaderboard. So I select these two.
That was a tip. Thanks. Good. Is that it? Thank you.
You can go.
Well, thanks again for coming. Thank you.